Hello everyone, welcome to my class, Math Lesson with Miss Kenny. Our lesson today is about using systematic trial and improvement methods to find approximate solutions of equations. The equations here are quadratic equations. Previously you have learned about how to solve quadratic equations using cross method, remember this? And then using quadratic formula. Now you are going to learn how to solve quadratic equation using systematic trial and improvement methods. Let's see. For example, use trial and improvement to find the positive solution to the equation. It means you have to find only the positive solution. And to the equation here is the quadratic equations, giving the value of x. The value of x here means the solution to one decimal place. To solve this using trial and improvement methods, first you need to draw a table like this. There are 3 columns. The first column is for x values, and then this is the equation, and then this is for command. Let's see how it works. First, since the highest degree of the x variable, which is this, the highest degree is 2, it means x squared. So you need to find a perfect square number nearest to 66. Let's try 8 squared. 8 squared is 64. So use the value of x equals 8. So 8 squared plus 2 times 8 minus 4 equals, okay, you can use your calculator here. Okay, to find it 76. 76 is more than 66. So the command here is too big. 76 is too big. And then reduce the value of x. Try 7, for example. So 7 squared plus 2 times 7 minus 4 equals 59. Okay, 59 is less than 66. It's too small. Okay. Now we have 2 values here. 8 is too big, 7 is too small. So you need to choose, or you need to try the middle value between 8 and 7. The middle value is 7.5. Let's use 7.5. So 7.5 squared plus 2 times 7.5 minus 4 equals 67.25. 67.25 is more than 66. So it's too big. You need to reduce the value of x. So let's use 7.4. 7.4 squared plus 2 times 7.4 minus 4. You'll get 65.56. It's too small, okay, because 65.56 is less than 66. Now here you have 2 values. 7.5 is too big, 7.4 is too small. You need to find the middle value between 7.5 and 7.4. The middle value is 7.45. Let's try 7.45 squared plus 2 times 7.45 minus 4. The result is 66.4025. It's too big. Let me put this into perspective. Okay, see this? 7.5 is too big, 7.4 is too small. Okay, and then you calculate the middle value, 7.45, and the result is too big. Since the middle value is too big, it means you have to round down. You have to choose 7.4 because you need to choose the value of x to one decimal place. Therefore, the value of x is 7.4. Let's see another example, real-life example. It means for length here, length cannot be negative. See what are the dimensions of this rectangle, which has area 30 square centimeters, giving the value of x to one decimal place. First, we need to formulate the quadratic equation. Okay, the area of a rectangle is length times breadth. So x times 14 minus x, okay, equals 30. Okay, 30 is given from the question. And then use expansion, x times 14, 14x, and then x times minus x squared equals 30. Now we have the quadratic equation. Let's use the trial and improvement methods here. See, the x squared. Find the perfect square number nearest to 30. Let's try 5 because 5 squared is 25. Use 5 and use it into the equation. 14 times 5 minus 5 squared equals 45. 45 is too big because we need 30. And then reduce the value of x into 4. Okay. And then calculate. You'll get 40. 40 is too big. Okay. And then reduce again 3. So 14 times 3 minus 3 squared equals 33. It's too big. 33 is more than 30. Okay, reduce again the value of x into 2. And then 14 times 2 minus 2 squared equals 24. It's too small. Now you have two values. 3 is too big, 2 is too small. You need to find the middle value. The middle value between 2 and 3 is 2.5. Use 2.5. So 14 times 2.5 minus 2.5 squared equals 28.75. It's too small. It means you have to increase the value of x. Let's increase into 2.6. So 14 times 2.6 minus 2.6 squared equals 29.64. Too small. Increase again. 2.7. Okay. 14 times 2.7 minus 2.7 squared equals 30.51. It's too big. Now you have two values. 2.6 is too small. 2.7 is too big. Okay. You have to find the middle value between 2.6 and 2.7. The middle value is 2.65. Use 6.25 into the equation. So 14 times 2.65 minus 2.65 squared equals 30.0775. It's too big. Okay, let's put this into perspective again. Okay, like this, right? 2.7 is too big. 2.6 is too small. And then find the middle value. The middle value is too big. It means you have to round down. Okay, we choose 2.6 then. X is 2.6. Now back to the question. What is the dimension of this rectangle? It means the length and the breadth. What is the length and the breadth of this rectangle? Okay. X, we choose 2.6. It means 14 minus x is equal to 11.4 centimeters. Okay. And then use answer statement. Therefore, the dimension of the rectangle are 2.6 centimeters by 11.4 centimeters. Okay, this is the example of real life. Next, use trial and improvement to find a positive solution to the following problem. The product, it means the multiplication of two consecutive whole numbers. Consecutive means following after another, is 12,656. What are two numbers? Okay, first we need to generate the quadratic equation. There is no equation here. So let the number be x. So the other number is x plus 1. So x times x plus 1 equals 12,656. And then expand to remove the brackets. X times x squared plus x times 1, x squared plus x equals 12,656. Okay, now we have the quadratic equation. It's time to use the trial and improvement methods here. First, you need to determine the value of x, right? Okay, but the number here, 12,656, is too big. What to do? Separate the last two digits, 5 and 6, and use only the first three digits, 126. Find the perfect square numbers that nearest to the 126. It's x squared. So x squared equals 121. And then add 0 to the number, so it becomes 110 squared is equal to 12,100. Okay, you have now get your last two digits back. Okay, so let's use the value of x equals 110. So here 110 squared plus 110, you will get 12,210. It's too small. Try again. Improve the value of x. Try 111. So 111 squared plus 111 equals 12,432. Too small. And then improve again. Let's try 112. Okay, 112 squared plus 112 equals 12,656. It's exactly. So now you have found the value of x. So using the answer statement, the two consecutive numbers are 112 and 113. This is how we use the trial and improvement methods. For question and assignment, please check your Google Classroom. See you later in Zoom meeting. Thank you for watching Math Lesson with Miss Kenny.